We're looking at factoring the difference of two squares, a squared minus b squared. Each of those words is very important. The first one is difference. In our formula or in our problem, we're going to have the difference of a binomial. That means we're going to have to subtract. Not a sum, not a product, but a difference. The other word is two. I have two terms, so I'm going to have a binomial. Not a trinomial. I'm looking at this as two different terms, the difference. And squares, perfect squares. You should know your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 11 squared is 121, 15 squared is 225. You should know those pretty much up to through 20. That way, whenever you see them, you'll recognize them, and it'll come pretty quickly to you. In all of these, we're looking at the difference of squares. In factoring this, you have this formula, a minus b times a plus b. If you were to FOIL this out, you would see that once you combine like terms, this is what you would have every time. The first term just says, what squared gives me a squared? Minus b, what squared gives me b? Easiest way to understand this is to get started. In this binomial, I have the difference, and I have two perfect squares. What square gives you x? What square gives you x squared would be x. Minus, what square gives you 100? 10. And the second parenthesis is the same thing. It would just be x plus 10. If you were to FOIL this out, you would have x squared, and then you have a positive 10x, minus 10x, and then lastly you will have minus 100. You'll notice that these two middle terms will always simplify, and you will end up with a squared minus b squared. So this first one is x minus 10 times x plus 10. In the second one, what you ask is what square gives you 25a squared? 5a. 5 squared is 25. Minus what square gives you 49c squared? 7c. And then I just have the same binomial, 5a plus 7c. Again, you can FOIL it out and check it. Number 3, what square gives you 196? It's one of those numbers that's just not in our easy repertoire of squares. So in order to find that number, you may have to take the square root of 196, because when you take the square root of 196, you're going to find that it's 14, which means that 14 squared gives you 196. So this is 14. Don't forget your variable d, minus, notice we have two variables here. Don't let that throw you off. Very simply, you kind of look at them separately, but they stay together. That would be fg. And then I have the same binomial, but it's a sum in the second one. In number 4, I look simply what square gives me 144, and that would be 12. But what I have different here is h to the 6th. When you multiply, you add exponents. So since I'm splitting this into two different binomials, I'm simply going to take half of this exponent. So that would be h to the 3rd minus what square gives you 9, that would be 3. Then I'm looking at j to the 4th. What is half of 4? And that would be 2. And then I have 12h cubed plus 3j squared. Now, whenever you go to check this, you'll notice that h to the 3rd times h to the 3rd, when you multiply, you add, so there's your h to the 6th. J squared times j squared, 2 plus 2 is 4. So that makes number 5 pretty easy. What square gives you 4? That would be 2. Half of 8 is 4 minus. Again, we have these two variables together, and we just simply take half of 2 and half of 6. So that's going to be m to the 1st, n to the 3rd. And then I have 2k to the 4th plus m n cubed. I throw in this last one because when I look at it, what square gives me 16? That would be 4. I can take half of 2. What square gives you 81? That would be 9. But this answer is prime. And for me, I write prime. Some books just rewrite the very question. There is no common factor here, nor is this the difference of two squares. This is actually the sum of squares, so we cannot factor it. The difference of squares, a plus b times a minus b, gives you a squared minus b squared.